Hey YouTube, welcome back. Today is the fourth episode of our system design series about designing a rate limiter. Today we will talk about the the I guess the leaking bucket algorithm. The bucket leaking algorithm. So if you basically if you didn't watch the previous video, make sure to watch them so you understand everything. If you watch the previous video but you didn't you just need a quick review, we'll make a review right now. We had a questions that called design a rate limiter, and as we always all the time that system design questions sometimes be like too vague, like design Twitter, design Facebook, design blah blah blah. And your job as an interviewee is to clarify, just take this question, too vague question, to clarify, to take clarifications, so you will understand the problems and know the actual requirements. So you will end up with designing the right part. Basically, each system design interview comes in four parts. We should understand the problem. We propose high level design. We take deep dive in one of the on one of the aspects basically, and we wrap up everything. And yeah, that's it basically. For our first episode, we first video about this series, basically we talked about how we can get the how to understand the problem and how to know the requirements, and we think that we should ask about like from 5 to 10 questions, depends on how complex the topic is. And basically these questions is to know what we are building, basically what specific types or request needs to what we're building as each. So basically we need to know which specific types of requests that we building this rate limiters. We should know how scale it is, and we should know so basically what is the scale of the system. We should know also the performance, about the latency and the requirements about that. The availability, we should know about them also, and we should know if the rate limiter will respond something, so about the functional requirements. So, and all the other thing, the last thing is that does the rate limiter work based on address or user ID, so to choose the right algorithm for that. So basically we ask all the questions needed to, so we can come up with the functional requirements and the non-functional requirements. So based on the question that we did ask, we get the functional requirements is the rate limiter must be able to limit the rate of the request for a specific type of requests. The rate limiter must respond to the user when the limit is exceeded. The rate limiter must be able to track the rate in real time. The non-functional requirements, it's the rate limiter must be high available. The rate limiter should has low latency. The rate limiter should has high fault tolerance. Basically, if we had any problem with the rate limiter, like failover, errors, anything like that, the system will continue working. Use as little memory as possible, and we make sure that it's in a distributed system. And when we know all of that, we started in the second part is to propose the high level design. And first is that where we should to put the rate limiter, and we know that there is two places to put the rate limiter. We can put the rate limiter on the client, or we can do it on the server. And if we on the client, we said that it will could make we will not have full control, so it will not act as we expected. If we do on the web server, we have two choices basically to put it into the API gateway if we have a microservice architecture, because this is the most common way basically to put where to put the rate limiter. If it's not, and our technologies will not help to put it in the middleware, we will put it with the web servers. But we went with the rate limiter as a middleware because this is the most known way basically. And after that, when we talk about where to put the rate limiter, we want to talk about which token, which algorithm that we use. So basically last episode we talked about the bucket token, And basically we have it's a quite straightforward that we have the limiter will be full of token, and each request requires one token to get access to the web server. And if the token if there is no tokens available, the all of the requests will be declined basically, or be declined with the error 429 429. And a lot of actually Amazon and Stripe uses this algorithm, and it's a pretty easy to implement. It's memory efficient, and it takes tons of traffic in the same time. However, the two parameters make it sometimes quite hard. And yeah, that was all of it. So basically, let's try today. So basically, let's just try today to talk about the. Yeah, by the way, if you like the way that I am, when we have a series, I'm describing all the things that was before, so we make sure that all of us in the same page. Just feel free to comment that. If you don't like it and you just want me to go directly into the subject, just comment about that. So basically, let's just try to talk about the main object today, which is the leaking bucket. Basically, the leaking bucket, it's quite similar. Wait a minute, let me just delete that. Okay. So basically, the leaking bucket basically it's quite similar to the token bucket. Expect that basically the requests are processed in a fixed rate, and basically the leaking bucket use the queue. It's like a first in first out. Basically the algorithm works as follow. Basically, we have the client again. Okay. Oh, sorry. We have the client, and basically when we go to access it, we have like some sort of middleware that ask a question: is the bucket full? And if the bucket full, we drop. If yes, we drop basically. If the bucket is not full, basically we put them into the queue, and we have this queue. And basically the queue is process to the web server in a fixed rate basically. And basically the leaking, basically when request arrives, the system checks if the queue actually is full. And if basically it's not, the request basically is added to the queue. That's it basically. Basically the requests are pulled basically from the queue and processed at regular time basically. Basically the leaking bucket takes also two parameters. It's a bucket size and the overrate. The bucket size is equal to the queue size, like how the size of the queue, like, or how many items can the queue handle. And the overflow rate is it defines how many requests can be processed at a fixed rate. And basically Shopify using this one. And yeah, and I don't know also, I guess Shopify and a lot of other e-commerce company. Actually, the pros is also memory efficient and give the limited to queue size basically. Requests are processed at fixed rate, therefore it's suitable for use cases that are stable outflow rate is needed. So the cons, I guess, is the two parameters is quite it's not that easy to implement, and the burst of the traffic fills up the queue maybe with old requests. So basically maybe you could have a lot of old requests, and maybe because of one of the requests takes too much time, so the request will be timeout and will be dropped. And yeah, this is was the problem with the codes basically with the leaking bucket. And I guess in the next video we'll talk about the fixed counter, and we will talk about the fixed window. And I guess the other three ones are like they are sometimes you feel that they look quite similar to each other. However, this is it for today's video, and hope that you like my description. And if you like my description, give me a thumbs up, subscribe to the channel, make sure to hit the notification bell, and yeah, see you in the future videos.